Hi, this is a question from the 2018 PM2 exam paper. So here we have a curve C. The curve C has equation y equals x ln x. The line L is the normal to the curve at this point P with coordinates EE. And obviously we asked to work out the area of this bounded region, which is bounded between the curve C, line L, and the x-axis. But the key thing here is that you're asked to work out the exact area and give it in the form a e squared plus b, where a and b are rational numbers. Numbers, obviously, that can be written as a fraction. Again, I want to emphasize on the word exact area. Okay, so that means if you're using a calculator, you may get the answer as a decimal and you will lose a mark. Exact means either as a fraction or in terms of E. If there's pi's in your expression, leave it in terms of pi or surds and etc. But avoid going into decimals, and if you do that, you will lose a mark. Okay, so I've drawn the diagram out here on this whiteboard. Right, so if you look here, I'm going to mark key points in different color, so it's easy to pick out. Coordinate P is the x coordinate is E and the y coordinate is also E. This is an important point that we need. So we need the area under the curve C between this coordinate here and the x coordinate of E. So we need this area here, and we need the area of this triangle. Okay, so let me just label this area A and area B. So we have split the area of the region into two parts, calling them A and B. Area A again is under the curve C between x values, question mark here, and E. And area of the triangle obviously is going to be base times the height, because that's the right angle here. Base times the height divided by 2. The height of the triangle is that E value there. And the base of the triangle obviously differs between this value and this value. So that's the base that we need to work out. Okay, so the two missing information is this value here and this value there. And once you work these out, then you're ready to tackle the question to working out the area of the region shaded. Okay, so let's start by working out the area of A. Now, to work out the area of A, we need this coordinate. This is the root, one of the roots of the curve C. The equation of curve C is y equals to x ln x. And it crosses the x-axis when y is 0. So if you set y equals to 0, you get x ln x equals to 0. And here, x and ln x are multiplying each other. So two factors times to give you 0. So one of them must be 0. Either x equals to 0 or you'll have ln x equals to 0. If ln x equals 0, then that means x must be equal to 1. So we have two solutions here. Obviously, we know that the origin is a root, and so the second solution is obviously the one we need. So this value here would be 1. Okay, so now we are ready to work out the area of A. The area of A obviously is underneath the curve C, banded between x equals 1 and x equals E. So it will be an integration between x equals to 1 and x equals to E of the equation for C, which is x ln x dx. And performing this integration will give you the area underneath the curve. Now, what type of integration is this? So obviously it's a product of two functions, and that needs to be tackled through integration by parts. Okay, so I'm just going to draw a line here so you can partition the board. All right, so integration by parts. So if there's an ln in your integration, the ln has to be the u, which means the x is your v dash. And integration by parts, so u equals ln x, so u dash equals to 1 over x. V dash equals to x, so if we integrate the x, we get x squared and a half raised by power divided by the new power. So integration by parts tells us that an integration of u times v dash is equal to uv minus the integration of u dash v. So we have uv minus integration of u dash v And if you look here, u is ln x and v is a half x squared. So that gives us a half x squared ln x when you substitute in for the u and v, minus the integration of u dash v. If you look here, u dash is 1 over x and v is a half x squared. So if you multiply, let's do it here, if you multiply 1 over x squared with a half x squared and simplify, obviously that will give you a half. X squared over x is just x, and that goes inside the integration here. Pull out the half, so all that remains inside the integral is your x, and we're integrating with respect to x. Any scalar factors, you're allowed to put it outside the integration sign. And if we integrate the x here, that will be x squared and another half. And if you just simplify all of that, so that's a half x squared ln x, and a half times a half, so that's a minus a quarter x squared. There's no need for a plus c. The reason is, I'm sure you know, is because we have bounds and it's from 1 to e. Okay, so just in case if you're wondering where we got this a quarter from, so when we integrate this x, we have a half. Don't forget, when we simplified the u dash v, we also had another factor of a half, and which we pulled out. So that half multiplied by that half gives you that quarter. Okay, so substitute in for the e. So that's a half e squared ln e minus a quarter times e squared. Yeah, don't need that. Minus, and then substituting for the 1, so that's a half times 1 squared is 1. Let me just put that in there for showing all the steps. And ln of 1 minus a quarter of 1 squared. Okay, and then just simplify this. This term here, ln 1 is 0, and obviously that's just going to give you minus a quarter. Ln of e is equal to 1, so simplify that, so we have a half e squared minus a quarter e squared. That's gone, and then minus and the minus gives you your plus a quarter. So we have like terms here, so a half e squared minus a quarter e squared is a quarter e squared plus a quarter, and we can also write this as a quarter bracket e squared plus 1. Okay, so this is the area of the region A. The important part is that it's in exact form. It's in terms of E, that we have no decimals. So that's the first part of the area worked out. All right, so the area of A we just worked out is this region here, this bit here. We now need to work out the area of B. Now, to work out the area of the triangle B here, we need to figure out what this value here is on the x-axis. It's where the line L, which is normal to the curve, crosses the x-axis. And to do that, obviously, we have to take a step back. We need to know what the equation of this line L is. We're given that it's a normal to the curve, which means it's going to be, we need to work out the gradient of the curve C at this point. And then do the negative reciprocal because it's normal means the right angle, and then use the equation of a straight line to work out the equation of the normal of L. So let's just put that there. So equation of line L. So y equals to mx plus c, or use the formula y minus y1 equals to m bracket x minus x1. So you have an option between which two to use. At the coordinate, obviously, that we are given is coordinate P, where the line goes through, which is EE. Let's start by working at the gradient of the curve C at point P. Let's say MC is the gradient of the curve C at point P. And this is going to be dy by dx. And we know that y is equal to x ln x. And I'm sure you figured out that we have a product of two functions and we want to differentiate this. So obviously, we have to use the product rule this time. And if you differentiate using the product rule is going to be u dash v plus u v dash. U is your x and ln x is your v. I'm going to go straight into differentiating without writing the u's and v's separately, because by now, if you have enough practice using product rule, you'll be able to do that yourself. So if we just substitute them in, so u is x, so u dash would be 1, v is ln x, and then plus u, which is x, and v dash is obviously going to be differentiation of ln x, which is 1 over x. And if you simplify that, we get ln x plus 1. So this is the gradient function of the curve C, but we want the gradient at P where x is equal to e. So the value of the gradient at C would be ln of e plus 1, and ln of e obviously is equal to 1, so 1 plus 1 gives you 2. So the relationship between curve C and L is that L is the normal to the curve at point P, which means the gradient of the line L would be the negative reciprocal of the gradient of the curve C. And that's going to be equal to minus 1 over 2. So now, to work out the equation of line L, we have an option between which one to choose. If we use this one, obviously we need to find what C is. If we use the second version, the standard form of the equation of a straight line, you can just put the values in and go straight ahead and find where it crosses the x-axis. So if we use the second version, y minus y1, which is obviously coordinate of P is e, so y1 is e, equals to the gradient, which is minus a half, bracket x minus x1, which is also e. Right, so now that we have a version of the equation of line L, for space, I'm just going to rub this bit off, as this bit is not needed anymore. Right, so we want to work out the x-coordinate of this point where the line crosses the x-axis. So at this point here, y equals to 0. And if you sub that into your equation of your straight line, we have 0 minus e equals to minus a half, bracket x minus e. And if we just rearrange that, so times both sides by minus 2, so we get 2e is equal to x minus e. That gives you the x coordinate as 3e. There you go. This is the coordinate at this point. Now, to work out the area of region B, we have this triangle here. There's a right angle there. This bit is e. This bit here is 3e. So the base of the triangle is going to be 3e minus e, so that's 2e. The height of the triangle is, it goes up to e. So the area of the triangle B is base times by the height divided by 2, and that's e squared. Again, an exact form. Therefore, the total area, obviously, it's going to be the sum of the area of A plus the area of B. And the area of A we worked out as a quarter of e squared plus 1 in a bracket, plus the area of B is e squared. Okay, I just noticed that the area here, in the form we need it as, it doesn't have any bracket. So we should just expand the bracket and just simplify. So we have a quarter e squared plus e squared plus a quarter, so that gives you 5 over 4 e squared plus quarter. And if you compare that with the solution here, so this is basically your A and this is your B. We can also just write them out separately. A is therefore 5 over 4 and B is equal to a quarter, and we're done.